Hello. In this video, we're going to be exploring integer exponents. You can see from the title that this is part 1. Part 2, I highly encourage you to check that one out as soon as we're done with this one. But let's get into some of the vocabulary. First is the integer. That is a whole number and its opposite. Whole numbers, 0, 1, 2, 3, 4, and so on. And the opposites, -1, -2, -3, and so on. Exponent, the number of times to multiply the base by itself, also known as raising to a power. And finally, the word base, which is the number being multiplied. And I can express it this way. We can say that we're going to do the base b is going to be raised to some n exponent. And it's done as a superscript, smaller number above there. Okay, so let's just take a look at some of them. For instance, an exponent of 2, which is to raise to the second power, also commonly referred to as squared or to square a number. So 2 squared, we're going to do 2 times itself. There's 2 of them, 2 2's. And 2 times 2 is 4. Next, we have 3 squared. That's where we'll do 3 times 3. There's 2 of them. 3 times 3 is 9. And it just goes on from there. What's 4 times 4? 16. 5 squared, or 5 times 5? 25. 6 squared, 6 times 6 is 36. 7 times 7 is 49. 8 squared, 64. 9 squared, 81. 10 squared is 100. And I highly encourage you actually to memorize these. It's not really a big deal to memorize your squares up to a certain point. In fact, you might find it useful to even include the numbers 11, 12, and maybe even 13 into what you want to commit to memory. But definitely the numbers 1 through 10. And, we didn't include 1 here, but, well, what is 1 squared? 1 times itself, or 1 times 1? Well, it's 1. 1 times 1 is 1. All right. Well, let's take a look at another example here, like the third power, okay, an exponent of 3, or to cube a number. First, that's 2 cubed. That's going to be 2 times 2 times 2. That's 3 of them. 2 times 2 is 4. Times 2 is 8. Okay? Same thing with 3. 3 cubed is 3 times 3 times 3. That's 3 of them being multiplied together. The first 2, 3 times 3 is 9. Times 3 is 27. Okay, and we keep going from there. 4 times 4 times 4. Well, these first 2, 4 times 4 together is 16. Times another 4 is 64. 5 times 5 times 5. Well, that's going to be 25 times 5. 125. 6 cubed, that's 6 times 6, or 6 squared, which we already know is 36, times another 6, which gives us 216. And finally, 7 squared is 49, times another 7 is 343. So that's what 3 7s multiplied together would give you. And these numbers, again, not going up quite as high. We didn't go all the way up to 10. But knowing these in your head would be particularly useful. Cubes up to 7. Not really a big deal. But let's take a look at some other exponents. And you'll notice on this page, I kept the base as 2 for all of them. But 2 squared, we already said, is 4. And we already said that 2 cubed is 8. So if we want to raise it to another exponent, 2 to the 4th power is going to be 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, we already have that, times another 2 is 16. And you can see the pattern. All we're doing is multiplying the previous one by 2. 2 to the 5th would be 2 to the 4th times another 2, which is 32. 2 to the 6th power is 32 times 2, which is 64. You might recognize that as 4 to the 3rd power as well. You'll see why that happens in part 2 of this 2-part lesson. 2 to the 7th power is going to be 2 times 64, or 128. 2 times that gives us 256, or 2 to the 8th power. Double that one, or multiply it by 2, you get 512. And finally, the last one, 2 to the 10th power, is going to be 2 times 2 to the 9th, which is going to give you 1024. And this is another place where I highly recommend that you memorize these, the powers of 2 going all the way up to 10. Not a big deal. You just start with 4 and keep doubling it on down the line. 4, 8, 16, 32, and so on. So let's take a look at the special case, 0. That means we're raising something to the 0 power, so we would multiply 4 times itself no times, or 1 times itself no times. Okay, this is just a rule. It's something you're going to want to memorize. Anything raised to the 0 power equals 1. 1 to the 0 power, or 0th power, is 1. 2 to the 0 power is 1. 3 to the 0 power is 1. 4 to the 0 power, 1. 5 to the 0 power, 1. 6 to the 0 power, 1. Okay? If I did 298 to the 0 power, what's that going to be? That's right. It's just 1. How about if we did the number -8 to the 0 power? What's that one going to be? It's 1. Notice the way I did the parentheses there. Something you want to pay attention to, because that's different from this. Because according to order of operations, the exponent happens before what is technically multiplication. So what we would have here is a -1. But that's a lesson for another time. Just keep in mind, parentheses, important. All right. So let's talk about the last type of exponents that we're going to deal with in this particular lesson, which are the negative exponents. And I went ahead and put down the formula here. X to the negative n power is the same as 1 over x to the positive n power. So as you see in our first example, 2 to the negative second is the same as 1 over 2 to the positive second, which we've already discussed, is 4. So 2 to the negative second power is 1/4. 2 to the negative third is 1 over 2 to the positive third, or 1 over 8. If the exponent is -2 here, it becomes +2 in the denominator. And 3 squared is 9, so the number we have here is 1/9. And that's essentially what we're doing, is flipping it upside down. We took 2 over 1, it became 1 over 2. 3 over 1 became 1 over 3. So in this case, 1 over 5 to the negative second power became 5 to the second power. That's 25. Or 1/2 to the negative fifth power is simply 2 to the positive fifth power, which, like we said on an earlier slide, is 32. All right. And that is the big idea for negative exponents, is all you need to do is flip it. 3 to the first, we already know, is 3. 3 to the negative first, flip it upside down. 1/3. 2/3 to the first power is simply 2/3. That's the identity. It doesn't do anything. So 2/3 to the negative first power, we flip it. It becomes 3/2. 5/7 to the negative first power, just flip it. 7/5. 28/13, and you can't reduce that. To the negative first power, all you have to do is flip it. It's 13 over 28. And that's part 1 of our lesson on how to handle integer exponents.